Hello, everybody. This is Mr. Fasoni. As promised, this is the last bit of Chapter 2.2, the last of the three forms that we have, intercept form. So I want to get into this, and we'll finish out this section with just another example. So let's get going. So concept 3, we're graphing quadratics using intercept form. I underlined this in the last video. So when the graph of a quadratic function has at least one x-intercept, the function can be written in intercept form. So at least one x-intercept, that's important. The function can be written in intercept form, which is f of x equals a times x minus p times x minus q, where again, a is not equal to 0. So you'll first notice right away that that a value is the same in all three of our different forms here. It handles the same thing in all three of them. If the a value is positive, we're going to have a quadratic pointing up. So a is positive, we get a quadratic that looks like this. And if a is negative, we get a quadratic that looks like that. So that controls our stretch and shrink and our reflection in all three forms: vertex form, standard form, and intercept form. And then a has to be not equal to 0, because if it was 0, we'd lose our x squares. It'd be 0 times whatever our x squared is, and it'd no longer be a quadratic at that point. We'd have either a linear function or possibly a constant function, depending on what else is going on. So I'm going to write this form over here again. So intercept form is function f of x is equal to our value a times x minus, so remember when we've got that negative sign, that is a hint that the sign is going to be different on the actual value or the coordinate of the point, or the value of p or q. It's going to be the opposite from what it is in the equation. So I had x minus, I'm going to make sure I'm using my colors correctly, x minus p, which I'm going to use orange for that, times x minus q, and I'm going to use pink for that. So in other words, whatever my p and q values are, the sign is going to be reversed from what we have in the equation. And these values correspond directly to intercepts, x-intercepts specifically. So that gives me the x-coordinate of my two x-intercepts, if I have two of them. I might only have one as well. So we get that. We can build our equation very quickly, and then, or build our sketch very quickly, I apologize. And then also we have a new equation for the axis of symmetry in intercept form. And this one is basically saying that any intercept that I have, so I've got an intercept here and I've got an intercept there. If I look at those, in comparison to the axis of symmetry, these intercepts are always going to be the same distance away from the axis of symmetry. The reason for that is because they're on the same horizontal line. They're both on the x-axis, so they're going to be directly across from each other over the axis of symmetry. So if my value for q, for instance, is a 5, and I shouldn't say that. Actually, that works. A 5, and my axis of symmetry, in this case, maybe my axis of symmetry is equal to 3. Well, the distance between 5 and 3 from the right side is 2, which means on my left side, I'm going to have a distance of 2 away from the axis of symmetry to get me my p coordinate, which in this case, 3 minus 2 would be 1. So that axis of symmetry is always going to be exactly in the middle between the two x-intercepts. So what that means then is that the axis of symmetry, I can find that by just setting up this simple equation where I take my p value and I add it to my q value and I divide it by 2. In other words, I'm finding the average of my p and q values, adding them together and dividing by 2. So that's a very straightforward axis of symmetry equation. Not as straightforward as the vertex form, but definitely easier to compute than the standard form. So these are the big takeaways from this. And remember, on a general graph of a quadratic, let's use purple. I've got some random quadratic here. I've got some important points, right? I've got my y-intercept. That's controlled by c in my standard form. I've got p and q. Q is my x-intercept, and p is my other x-intercept. The order doesn't matter. Just know that one is p and one is q, and they control the x-coordinate of the x-intercept. And then we have our vertex and our axis of symmetry. Our axis of symmetry, if we're talking about vertex form, our axis of symmetry is going to be h, and also the vertex itself would have the coordinates h, comma, k. And then finally, that a value, like we mentioned before, the a value, if positive, then my whole function is going to point up. And if negative, the whole function is going to point down. So there's a lot of different things that are controlled by these different functions. The a value is in all three forms. The b value and c value are both in standard form. H and K, I'm using the same color for B and C and H and K. I apologize for that. I need to find a better color setup for this. But H and K are both in vertex form. And then finally, my last two, the new ones that we learned about today, P and Q. I think I just reversed those, didn't I? Let's keep it consistent. P and Q are values that specifically show up in intercept form. And then on top of that, I've got three different axis of symmetry equations. Vertex is the simplest one. It's just that x is equal to h. Standard form is the toughest one to remember, but it's still not that bad. It's x is equal to negative b over 2 times a. And then finally, intercept form has its own axis of symmetry equation, and that is x equals p plus q divided by 2. So I'm finding the average of p and q. So no matter what form I'm in, I can always find the axis of symmetry. Because I can find the axis of symmetry, I can plug that x value right back into the equation, and that will give me my y value for the vertex as well. Once I've got the vertex and the axis of symmetry, then any other points that I have based on my equation, I can mirror if I need to. So for instance, if I'm in standard form, I can always mirror that C value. In this situation here, that would mean that I have a reflected C value on the other side, and now I've got some extra points that I can graph with. If I'm in intercept form, I can always graph my x-intercepts. Remember that C value also was the y-intercept. So I mirrored the C value, which was my y-intercept. In intercept form, I've got my two x-intercepts, which are mirrors of each other. And then other than that, we've got our vertex, which we've got already from vertex form automatically, or we can calculate it out using the axis of symmetry and plugging back in the other two forms. And from there, we get the general shape. And of course, A controls the up or down of the actual function itself. All right, so let's try an example here. We want to graph, and in my case, we're going to sketch f of x equals -2 times x plus 3 times x minus 1. So first thing is I'm going to identify my three values. A is -2. Next one after that is my p-value. If I've got a positive 3 in here, remember the p-value is always flipped. So p is -3. And then my q-value, if I've got a -1 there, that means my q-value is +1. So I've already got 3 pieces of information. And what we want to do is we want to find the x-intercepts, the vertex, and the axis of symmetry. Well, just with the information I have right now, I could actually graph my x-intercepts right away. Because I know that p is -3, I can just count off 1, 2, 3 to the left, and there is my x-intercept. And that's going to be at 3 or -3, comma 0. Same with q. I can go 1 to the right, and there's going to be my other x-intercept at 1, comma 0. So I've already got 2 points automatically graphed, and I haven't done anything. I just looked them up in the equation. I haven't done any actual arithmetic or anything. So next stage, I want to, I've got my x-intercepts done. So these are done. Next up, I need to get my vertex and my axis of symmetry. Well, I can't get the vertex until I have the axis of symmetry in this case. I'm just going to plug in my p and q values. Remember, x is going to be equal to p plus q divided by 2. Well, my p value is -3. My q value is +1. I add them together. I get x equals -2 divided by 2. So x equals -1. So there's my axis of symmetry. And that makes sense. If I count between these two values, -3 to +1, that's 1, 2, 3, 4 units, right? Well, that means the middle point of it is going to be 2 units across, which would be at -1. So I'm going to zoom in on this a little bit and draw my axis of symmetry. Just a dashed line. Remember, this is a sketch. It doesn't have to be perfect. And in my cases, it won't be perfect, even if I'm trying my very best, because my art skills are not the best. So I know now that my axis of symmetry is right through the line x equals -1. I've got almost everything I need. Since I've got my axis of symmetry, I know I've got the x value from my vertex. I just need the y value. So that's the last thing I need to do. Give me that y value. Well, to do that, all I have to do is plug the -1 right back into the equation. So let's go ahead and do that really quick. let's see here, I've got -2 times x plus 3 times x minus 1. And in this case, my x is going to be -1. I plug those both in, do some calculations. I get -2. -1 plus 3 is +2. And -1 times minus 1 is also -2. So we got -2 times +2 times -2. Negative times negative becomes positive. So 2 times 2 times 2 gives me 8. So in this function f of x, when I evaluate the function at -1, I get -2 times -1 plus 3 times -1 plus 1, which gives me +8. Which means when my x value is -1, my y value is +8. And now I've got my vertex. So I've got all the data I need now. I can put my vertex on this sketch as well. My vertex is way up at +8. I'm just going to say it's here. It's not really, but it's close enough. And now I'm going to draw my my graph. I'll use yellow. And my graph is going to look something like this. There we go. I don't have my y-intercept because I'm not in standard form. But if I wanted to calculate that very quickly, all I would have to do is plug a 0 in to my equation. If I plug a 0 into my original equation instead of a 1, I'll get f of 0 equals -2 times 0 plus 3 times 0 minus 1. Do the math. -2 times 3 times -1. Well, 2 times 3 is 6. Negative times negative is positive. So when I'm at 0, my y value is 6. Oops. So I could then label this y-intercept if I wanted to. My y-intercept is going to be 0, 6. All right. Oh, and I should have labeled my vertex. My vertex is -1, 8. So I've got all the major points covered. I've got my x-intercepts, my y-intercept, which wasn't required on the problem. I've got my vertex, and my vertex gives me the axis of symmetry. Side note, remember the axis of, or the vertex also gives us the maximum or minimum. So also my maximum is 8 because that's the highest point on the graph. The graph goes all the way up to the value 8. All right. So that's the example with 2 intercepts. Now I just want to show you what one intercept would look like. This is the last thing. This will just take a minute. If I've got one intercept, what happens there is my graph of my quadratic is going to be having its vertex right on the x-axis. That's the only way we can have one intercept, because the second the quadratic drops even a slight bit underneath the x-axis, that means I've got 2 intercepts. And if it doesn't touch the x-axis ever, then I've got 0 intercepts. So in a situation with one intercept, that means my p and q values are both the same because there's only one location. So that would mean that p is equal to q. So if that's the case, then if I write my equation out, I have something that looks like this. I get a times x minus p times x minus q. if P and Q are the same value, then really I can change either one to whichever value I want. So really, I could write it as A times X minus P times X minus P, because P and Q are the same. Well, I can then simplify this. A times X minus P times X minus P is the same as saying A times X minus P squared. Well, now this is starting to look like vertex form. And sure enough, if I've only got one intercept, that means the X value of that intercept is going to be the same as the X value of the vertex. So in the case of one intercept, vertex form and intercept form are virtually the same thing, because my Y value is 0 and my X value, or I'm sorry, my K value is 0 and my H value is also going to match this value P. So let's go over a real life example of that, because I think with the letters it kind of gets confusing. So let's think about this following equation. I've got the equation y equals, or the function y equals 7, that's going to be my A value, times x minus 5 times x minus 5. I'm going to erase this stuff over here. So this is my equation. I'm looking at this in intercept form. This is my A value. This 5 is my P value. And this 5 is my Q value. So A is equal to 7. P, in this case, is going to be equal to positive 5. And Q is going to be equal to positive 5 as well. So if I were to graph that, that means my P and Q values are the exact same spot. 1, 2, 3, 4, 5. This is my P value and my Q value. They're both intercepts because it's intercept form, which means then I could rewrite this function really, because they're both the same, as 7 times x minus 5 squared, which now makes it the same as my H value. H equals 5 from vertex form. I don't have a K value. My K in this case is technically 0. So my K equals 0. Well, if we look at that, the coordinates are going to match. The coordinates of this intercept is 5, comma, 0. So intercept form with one intercept is actually the same as vertex form, where the K value is equal to 0. And at that point, I'm basically done. I can sketch this out very quickly. I know my A value is equal to 7, so my graph is going to be very steep and point upwards, and I just do that. There's my function. And then my axis of symmetry. Well, my axis of symmetry, if I'm in vertex form, I know it's 5. It's going to cut right through the middle. X equals 5. I don't have to do anything in vertex form. I get it automatically. If I'm in, if I stay in an intercept form, it still works the same way. X is going to be equal to, well, I've got my P value and my Q value. I'm adding them together and dividing by 2. Well, 5 plus 5 divided by 2 is just the same as 10 divided by 2, which is equal to 5. X equals 5. X equals 5. So intercept form is nice when we have the actual intercepts already, we can build the equation very quickly using those intercept values, and then we can multiply through if we want to convert it to another form. So I guess I should show that very last. I'm going to go back to our equation that we had in the first example. This is the last thing, just that last connection. Remember with vertex form, if I have vertex form and I multiply it through, I ended up getting standard form. Well, the same thing holds with intercept form. If I multiply all this through using the order of operations, what I end up getting is another equation in standard form. So I saw this -2 here. It's going to be -2 times, let's do my FOIL method, x times x is x squared, x times -1 is -x, 3 times x is 3x, and 3 times -1 is -3. Combine the like terms, and I get -2 times x squared plus 2x minus 3. Last step, I distribute. Get -2x squared minus 4x plus 6. Now I'm in standard form. So if you're in a form that you don't necessarily like, for instance, if you're in vertex or intercept, you can use our friend PEMDAS, the order of operations, on both of them, and the output will give you standard form. Now, I would not be surprised if most people don't like standard form. It's probably the roughest one to use. Intercept and vertex form give us more information right away. But what's nice is if I start in one, I get as much information out of it as I want, or as I can. I go through the order of operations, and I have standard form, which gives me a little bit more information, like the y-intercept. Then I can build more information on my graph fairly easily. So vertex form gives me the vertex. Go through PEMDAS, get the y-intercept. If I start in intercept form, that gives me the x-intercepts. Again, I go through PEMDAS, and I get my y-intercept at the end. I just want you guys to see that connection between all this stuff. We'll talk more about it as we go forward in this semester. All right, so I'll go ahead and put this up on the website and on my YouTube channel, and then there will also be a assignment that deals with this a little bit, probably about 7 questions, and that will be due on Tuesday at 11:59. All right, guys, have a great weekend, and I'll see you then.